Good morning. Welcome to Studio Offshore Energy by TKI Wind op Zee. My name is Bob Meijer and I'll be hosting this morning session for you. I also want to say welcome to the guests who are watching from remote and also the guests that we have say in the virtual studio. Wiep Volkers from TNO. Brigitte Vlaswinkel from Oceans of Energy and Don Hogendoorn of Solar Duck. This short session is on the topic of offshore solar energy. We think it's a very promising technology with a huge generation potential. This is also reflected in the government roadmap for floating solar solutions. So there is definitely a perspective on upscaling of this technology on the longer term. To unlock this potential, we still need to address a couple of potential challenges. We need to learn and develop new technology and make it to make the scale up really feasible in terms of cost, in terms of spatial integration. In terms of material use, ecology, so many topics that need to be addressed. And we've asked TNO to outline for us the state of the art of offshore solar energy and to investigate what the major challenges for upscaling are. And this is of course relevant for the industry, but also relevant for our TKI innovation program. So this program is very much targeted at resolving those challenges. Just some logistics before we kick off. There is the opportunity to ask questions in the chat. We may not be able to answer all questions, and we'll come back to you with answers later on in a follow-up email. That will also include the presentation. Also, please note that this webinar is being recorded for future reference for people who could not attend it live. Please take notice of that. And I'd now like to start the webinar with the presentation of the offshore solar study by TNO. Wiep Volkers from TNO, the floor is yours.
Hey, thank you, Bob. Good morning, everybody. I prepared a few slides. It's very helicopter-like, but I think it gives the essentials. I'm now sharing the screen if that indeed works for everybody. Yeah, is it? So let's start with, offshore solar. There is already a lot of talking about offshore solar and why is it so important and promising. And the key answer to that question is because we are looking in the Netherlands and other places similar, but let's start the Netherlands. We are looking for, let's say, order of magnitude 1,000 square kilometers to deploy solar energy. And the North Sea is where we can find that. You see here the map of the Netherlands with the economic zone of the Netherlands in the North Sea, and you see that there is where the square kilometers can be found. On land, it is very busy. Every piece of land already has a destination, but on sea we can find those square kilometers that we need for the climate transition, the energy transition. The other important topic, and which also develops defines the development directions that we are going in this sector, is that offshore solar and wind offer important synergies. So in this map you see where the offshore wind parks are, or where the offshore wind parks have been planned, and these are also the areas that first come into the picture when we talk about offshore solar, and I think for some good reasons of potential synergies. As Netherlands, we have this vision of building things on sea. There are visions about energy islands, about power hubs, and pictures like I'm showing here. At this point in time in Europe, the Netherlands, together with Norway, is leading the sector of offshore solar development. And another bonus, I would say, is that on sea there's more irradiance from the sun than on land. So as bonus, we get also a higher power yield from the solar energy that we deploy at sea. So Bob talked about briefly about developments that are going on, and in a very brief overview, we see that different types of approaches or concepts are under development in the different countries in Europe, with a focus on the Netherlands and Norway. So as number one, the elevated platform. So the basic is you design a stable platform several meters above the waterline, and that is where you place the solar system on. So Solar Duck is one of the companies that is working on this type of approach. Then as number two, what we could call a pontoon type approach, where the solar system is really close to the water level, and the platform itself is the floating platform, to put it like that. So Oceans of Energy is one of the pioneers in developing this approach for offshore solar. Then there is the approach to really look into a mattress-like approach that fully moves with the waves. We may call it soft and flex. Although, of course, there is a gradual distinction between pontoon and soft and flex, because a pontoon concept is always also composed of different sub-elements that also have a relative movement towards each other. And the final one, especially from the Norwegian companies, is based on the well-known technology of fish farms. And this technology can be extended or used for also developing offshore solar, where there is a membrane which is stabilized with a ring, and on top of the membrane you can design a solar installation. So Bob mentioned already the challenges that the sector is working on today, and we have in the meeting representatives from Solar Duck and Oceans of Energy, and they are also working on these challenges. So number one is how to design and construct such a system that will survive the circumstances on the sea, and also how to prove this survival. So it is an interaction between development of calculational methodologies, and on the other hand, really making the designs, do scale model testing for those designs, build pilots, see how they behave, measure how they behave, couple it back to the methodologies, and in that way build up the knowledge on how to build such floating structures in a cost-effective way on the sea. Operations and maintenance for sure has its challenges, and there is also work to be done and more knowledge to be built up over the coming years. It is about the PV system itself, the modules and the electrical components, how to make them survive, how to do the maintenance schedule for that in an effective way. All type of fouling prevention and fouling removal on the bottom side and on the top side, organic and inorganic, optimizing maintenance schemes, and develop also digital twinning approaches to enable this optimization of O&M. Number three, everything that has to do with the power production and the LCOE. Of course, this is the key thing. We're doing everything because we want to produce power. It's not simply because of building islands for the fun of it, but because we want to produce real substantial amounts of kilowatt hours on the sea. And to judge investment proposals for this type of installations, we really need validated power yield models. We need reliable models for cost and how scale effects and other effects affect this LCOE cost models. Societal acceptance is very important. I name here a number of those aspects. Circularity, so recycling and other parts of circularity, ecology, interaction with other uses of the sea, and that all comes together in permitting and permitting frames. So if I summarize this very short introduction, I want to say offshore solar is promising. It is very important. It can be the solution for the large-scale solar that we need. It is also challenging. Innovation investments are needed from the sector, working together with governments and knowledge institutes. And there are different concepts are in development, and all those concepts have their specific advantages and values and promises. Pilots and demonstrators for accelerating the learning curve are underway, are in place, but more of them are needed in this way towards scale up and in this way towards, let's say, winning the confidence of the world that offshore solar indeed is a solid solution to this challenge. Strong pre-competitive research programs can address those main challenges. That's it from my side as an introduction, Bob.
Well, thank you very much, Wiep, and absolutely interesting. I just want to point out that in the chat, Maaike has dropped the link to the report that TNO has produced. Yes, maybe, and reflecting on Wiep's presentation and the content of the report, I'd like now to open the discussion also with Brigitte and Don. Brigitte Vlaswinkel from Oceans of Energy. To start with you, Brigitte. Do you recognize the challenges that Wiep just presented, and do you think you can overcome them in say the coming 5 to 10 years?
Yeah, thanks, Bob. Thanks, everybody. Good morning. Yeah, first of all, I'd like to say that it's fantastic that TK Wind op Zee. So thank you, Bob. You TK Wind op Zee commissioned the report, and also indirectly RVO and the government basically sees the enormous potential of offshore solar for our country and also for the world, and really wants to learn now about the challenges that we have had and see how we can tackle that together. So I think that is just, first of all, great realization. Thank you for that. We are convinced offshore solar is a game changer for the world. I think Don also is with me on this. Yeah, there are definitely a few challenges that we still need to tackle. I think also for the report, I'd like to say one more thing. There's a lot of information is there. I think it is mostly talking about the technical challenges that we still need to tackle. Yeah, there's also other challenges that we still need to tackle, and that's basically more my field. You know, we really need to see how we can do this multi-use within the wind parks, how we can get the wind park operators on board. We need to really understand cumulative effects of offshore wind and offshore solar. This is something really important that we've been working on. Biggest challenges for us is basically that technology is ready. Now we need to upscale, large scale. For that, we need a grid connection at sea. And we need to change We need to have some changes in the law. Electricity law still needs to be changed, but those are kind of minor things. Most important things is that we can go with a large pilot, starting with 15 megawatts, but very soon, within 2-3 years, we can really move to larger pilots and get connected at sea. This is basically the most important thing that we are facing now.
Yeah, so it's really learning by doing, by having, say, larger pilots with all the facilities that you need to be able to further develop your technology.
Exactly. What we've learned 3 years at sea is just incredible, and you cannot really model that. You just need to go out there at sea and test it. And we've done this now standalone, 12 kilometers offshore, so really full seas. And now the next step is to take this into the wind parks.
Yeah, yeah, very interesting. Thanks, Brigitte. I'll come back to you with some more questions on this. Don, in also reflecting on the presentation from WEEP and the contents of the report, do you recognize those challenges? And also maybe a question to you, what do you really need in terms of further developing your technology?
Yeah, thank you for this invitation. I fully agree with Brigitte. It will be for scaling. It is important to have those access to the offshore wind farms, and we should see whether we want to go inside the new to be developed offshore wind farms. But even more interesting, I think, is to go into the existing wind farms and how to cooperate with existing wind farm owners to get this, let's say, more risky technology out there and integrate it in their inter-array cables. I think that will be if the government could arrange that from the government perspective, that would help a lot. And I think also on the integration, I think there's still a lot to learn on the technology side. On the if you integrate offshore wind turbine with an offshore floating solar farm, how will that work out? How will the inter-array cable, which effects will occur? But also the dynamic export cables and transformers, floating transformers, that are all, I think, research topics which are for both parties of interest.
Yeah, so that also requires what Wiep suggested, kind of pre-competitive research, independent of what technology you're using for the systems itself. There are common problems to be addressed as well.
Yeah, indeed. I think so.
Yeah, that's relevant information also for the research program.
Yeah.
I also see a question in the chat from Hans to see how big this can become. Do you have some scenarios on how many gigawatts we could harvest realistically by 2050? And Wiep, maybe you can reflect on that, on the actual potential in the North Sea. Do you have any ideas about this?
Yeah, so what would be ultimately possible is maybe another question from what is a realistic scenario. In most realistic scenarios, the total amount of solar energy in the Netherlands is typically 200 gigawatt in 2050. And I believe that 25% of that, so 50 gigawatt, will be placed on the North Sea.
Yeah, that's a huge number. So it's on a similar size of the rollout plans for offshore wind. And of course, then it becomes also interesting to integrate those. Both Don and Brigitte mentioned the integration with offshore wind farms. I can also point you to a study that was recently published by TKI, also with support from TNO, on, say, the generation profiles of wind energy and solar energy offshore. And that also gives a very promising result. So we see there is a negative correlation, which is a positive effect, I would say, for the energy transition. So so that's also a very interesting aspect of this integration. Going back to some further questions, we've also mentioned the LCOE. That's of course something that is always a striking thing with if you start installing solar farms offshore. The first reaction could be, yeah, okay, but onshore is so much cheaper. How can you come close to, say, to be on par with, for example, offshore wind or other technologies? Maybe Don, you can start to reflect on that. Is that a long way is it learning by doing? Are there some breakthroughs to be made? What's your view on the LCOE?
Yeah, I can start with that. Yeah, first of all, I think Weep's estimate of 40 gigawatt is even a bit low. We made some plots of if you put 130 gigawatt, what government ambitions are on land, then you mainly have to cover the entire Flevoland to do so. So that requires such enormous space on land that you'll get quite some protest, I believe. So it will be pushed offshore, just the same as the wind industry has gone from onshore to offshore. And its cost is important. I fully agree on that. But at the moment, I think a key, what's maybe even more important is the space availability and the grid availability. You can install new grid cables on land. Or you'll use the existing cables infrastructure which we already have offshore. So that makes it the picture completely different. And you want to have grid stability. That also is becoming much more important these days. So in the end, I don't believe it will be cheaper than offshore wind. That we have just a very high capacity factor here in the Netherlands, and especially with the monopiles, we're doing very great work. But in the end, I think we can bring down the cost in the future below 10 cents per kilowatt hour. But that's of course on the long run, not today. And I think it would be very important to strive with the Dutch government on an SDE scheme, which allows for that development over time. Just similar to the offshore wind industry, you start with a high SDE scheme, and with installed capacity, cumulative capacity or something like that, you let the SDE scheme slowly reduce. And then still you have the benefits of the combination and the reduction on your, you don't have to buy an additional substation and export cable.
Yeah, so that would mean, say, a policy that would increase the volumes of offshore solar, while also having cost reduction targets, similar to what we've seen in the past for offshore wind. Yeah, interesting.
And then maybe also to add.
Maybe one quick remark. So for offshore wind, it took, I think, 25 years to get to this cost level. I think for offshore solar, we can do faster than that, for sure. But of course, we need to have this support and this opportunity, but we can do faster than offshore wind. I think probably in 2030, we can already be at 15 cents per kilowatt hour. Would be my estimate.
Yeah, very promising. Absolutely. Yeah. So
I would like to make a comment. I think we could be even faster there, and it all has to do with how much you can produce, right? So if we have the ability to roll out large pilots sooner, then we can get the LCOE costs down sooner. And we think by the turn of this decade, around 2030, we can definitely be competitive with offshore wind at the price of in 2019. So it's just, you know, it's a dynamic curve. It depends on how quickly we can develop.
Yeah, and of course we talk about LCOE, but you must take the wider, say, system perspective, as Don also suggested. So that there are those benefits of stabilizing the grid and balancing. These are also, say, financial benefits, clearly. So I think this must also be taken into the scope of the LCOE and not just the generation cost. So we talked about some of these challenges, and Brigitte, you already mentioned that you have say are more involved with the say environmental side also of floating solar solutions offshore. What is your view on say ecology, but also maybe on circularity? If we start scaling up, we are also faced with say potential new streams of materials. What's your view on that?
Yeah, exactly. Well, to start with the ecological impacts, we have been we've been in the water since 2019, and that's really when we started monitoring already. So we know quite well what is going to happen, at least on small scale. And there's also quite some interesting positive effects that can happen with offshore solar. And what is also very interesting is that there are certain negative ecological impacts of
I think we...
okay, let me say it again. An offshore solar can have exactly the opposite effect. So effects of those two technologies can basically counterbalance each other.
Okay, so
you're always going to have effects when you place infrastructure at sea. So you really need to kind of look for this win-win, where certain impacts of offshore solar can be really beneficial and mitigate certain negative effects of offshore wind, and vice versa, of course. But for sure, what we see is now in the pilots offshore is that we are, of course, there is fouling on the underside of the platforms in the water, and this attracts all kinds of life. And we actually even measured, or we actually even saw in the environmental DNA samples that we took, that we saw certain fish species around our solar farm that you would never otherwise expect to see in the open North Sea. Yeah. So it's really very interesting, and it's not something that you can that you can see on a small scale. What will be the effect of large scale for the combination of offshore wind and offshore solar? For that, we need to model effects, and to make the models actually make sense, we need good input data, and for that, we need to have the field data to collect that. So I've been saying for a few years already, we need a ZOZAP next to
of course,
where the government also pitches in and also reaches out to the research institute and says, okay, let's research this. This is really a big opportunity. So
maybe just a couple of words, if you're looking at the clock also, on circularity. Can you say something about this? Is this, say, an investigated territory, or are you working on that as well?
Yeah, we are working on that, and we are really, we are working with materials that are already in a second lifetime, so recycled materials. And there is definitely more room for improvement from the entire circularity community to work with this, to work with us on this topic.
Yeah.
But this is the same for all, supplies we need. We need to be able to work a little bit more circular with the materials that we are using. Otherwise, this world is going to run out of resources.
Yeah, and we're still at the beginning of this upscaling. So now is the time, the right time to work on these topics, and not in 10 years when you're scaling up to gigawatt sizes.
But compared to offshore wind, or compared to the turbines, I know there's also advances being made there. But for recycling, it's much easier to take the components apart and recycle them. For PV, I'm not an expert on that. I think there's also progress being made there on how to recycle the solar cells.
I see Don also nodding. You agree with this, Don?
Yeah, I fully agree with this view. And it will develop, I think, also the same as the offshore wind industry. There also not everything is circular at the moment, but it's important aspect to take into account from the start.
Yeah, well, I want to thank you very much. I look at the clock. We still got 2 minutes, but people probably have to go to other meetings. And I think this is the first time that we did this kind of breakfast-like session with Studio Offshore Energy from TKI Wind op Zee. So I want to thank Wiep for presenting us the report in an overview. I want to thank Brigitte and Don for participating in the discussion and your openness with this. I want to thank you as audience for asking questions. I know not all questions have been answered, but we will come back to that. And I still want to point out again to the report, which is on our website, and the link is in the chat for further reading on this very important, I would say, and promising development of offshore solar. So thanks again, and I wish you a very sunny summer holiday, and we'll be back with further events from TKI Wind op Zee. Thank you very much.
Thank you. Bye-bye.